Hello everyone, today we're going to be looking at usaco-training job processing. In this problem we're going to be given n items or n jobs. And then we're going to be given some type A machines. And we're going to be given some type B machines. So what's going to happen is that with these n jobs, we're going to first place all of them in the input container. So they're just going to be lurking over here. And then we're going to let each of these n items get processed by exactly one of these type A machines. And then after it gets processed, we're going to move it to the intermediate container where it's going to belong here. And after an item gets to the intermediate container, we can move it into the, we can let it get processed by one of the type B machines. And then after that, we move it to the output container. So what we're going to be given is that the time for each machine to process an item. So for example, if you take a look at this input, you're going to see we're given 1, 1. Okay, so this means for this 1, it means that the first type A machine would take 1 unit of time to process an item, and the second one means that the second machine takes 1 unit of time to process an item. And here the catch is that a machine can only process one item at one time, and an item needs to be processed by the type B machine after it gets processed by the type B machine. So you can't let it let it be processed by a type B machine then by A. You have to go in the order from A to B. So then what we're going to do is that given these n items and these machines, we're going to calculate the minimum time to perform all the type A tasks and the type B tasks. So over here, I'm just going to briefly explain the input. So we're going to give an N5 over here, which is the number of items or jobs. And here we're going to be given the number of type A machines and the number of type B machines. And then on the next line, we're going to read some integers. So the first M1 integers are going to describe the time it takes for the type A machines to process a product, and the rest are going to be the time for the type B machines. Okay, so our output is just going to be containing two integers. One integer is going to be the minimum time to perform all the type A tasks, and the minimum time to perform all the type B tasks. Okay, and again, the type B tasks require the type A class. So then I'm just going to go here. I'm going to explain it. All right. So we're given 5 items. 1, 2, 3, 4, 5. And let's look at the type A machines first. So we have 2 machines, each with speed of 1. So what we can do is that we can assign this to this, this to this, this to this, and this to this, and this to this. So then what we're going to end up with is we don't actually really care about the order we process them in. So let's just say we process this first. So at time 1, this is going to be done. And then at time 1, this machine's going to be free, so we can give it for this product. So we have 2 and 3. And over here at time 0, this machine is also free, so we can do this item. So this would be 1 and 2. Alright. So then our answer for the type A task would be 3, because it would take a total of 3 units of time to process all the tasks containing the type A machines. Okay. So now we also need to calculate the type B machines. All right. So our 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 machines are 1, 3, and 4. All right. So again, we're going to, let's just say so we have these, right? So let's just say we assign this to this, and then we also assign this to this, and then we can assign this to this as well, and we can just do some guessing and checking, and over here, let's just say we assign this to this and this to this. All right, so let's calculate it. So we're going to have here is that let's say you process this item first. Okay, so at time 1 it's going to be free, and over here you have your 1, so it would end up at time 2. And then at time 2 this machine is going to be free, so you can process this item. So then it would take 1 unit of time to process. So then you have your 3, and then at time 3 both of the machine and the product will be available, so you can assign it to this, and there you have your 4. So then over here, we say that this machine is going to pair with this product. So at time 2, this is going to be available, and then what we're going to do is that it takes 3 units of time to process, which would sum up to a total of 5. And over here, you would pair this with this. It's free at 1, and over here, the what do you call it? It takes 4 units of time to process, so this would be equal to 1 plus 4, which is going to equal to 5. All right, and again, you take the maximum of this since you're getting the time it takes to perform all tasks. So then you take the maximum, which is 5, which is the answer for our input. All right. So, well, this is just the input, but now we have to form some kind of solution to solve this problem. All right. Okay. So, let's first solve for the top. Okay. So for the type A task. All right. So we have our nodes. All right. And we also have some machines. So we have A1. And what AI here is the time it takes to process the product. All right. So you all know that that at time 0, all the machines and the jobs are going to become available. So let's give them a time 0, 0, 0. Now here, what you're going to do is that you want to like quickly assign the smaller times first, so then you can kind of stack them up. So what we're going to do here is that we're going to sort our machines by their time. So then we're going to ensure that that A1 is less than A2, is less than A3, is less than A4, dot dot dot, which is less than A1. So then this would be basically, or let's just make this less or equal. This would be non-decreasing. So then what we're going to do is that we're going to assign this to A1. And then what's going to happen is that A1, you know that it originally takes A1 time to process an item. But then after you assign it, it has to use this A1 first. So if we're considering putting another A1 in, or if we're assigning another task to A1, since it has to process this task first, by the time it has to process this task, it would take a total of A1 plus A1 time. All right, so you may notice that over here, you like you might assign multiple tasks to the same machine, because let's just say you have something like, so again you have your tasks, and then you have your machines. So your machines might be something like 1, 1, 5, 10. So obviously you want to assign this task to this machine. So then and then you're going to assign this to this to this, and by time you can also assign this to this. And this is because it takes a lot of time for the second machine to process the item. So then what you're going to do is that you're basically going to try to maintain a sorted list. Okay. So what's going to happen is that, okay, let's actually get rid of this. So let me erase this too. And this are. So over here, what we're going to do is that we're going to assign the first to the first, and then we're going to change this to A1 plus A1, and then you're going to go to this node, and you're going to get the minimum of the updated list and the rest of the list. So let's just say A2 is smaller, so then you're going to assign this to this, and then you're going to change A2 to A2 plus A2, and then after this, we're going to look at the next item, and we're going to again get the minimum of the rest of these items. So then we're just going to keep on repeating this process until we finished the last item. Okay. So then, how are you going to calculate the total time, or the time it takes to complete all these tasks? Okay, so you notice that these start at 0. Okay, so at time 0, you can start processing this task. So then what's going to happen is that the first item over here is going to get processed at time A1. Okay, and according to this diagram, the second item is going to be processed. It's going to be finished processing at time A2. So then let's just say you want to assign this task to this A1 plus A1. Okay, so this means that the A1 plus A1 is less than or equal to A3, and A1 is less than or equal to A2 plus A2. And this is always true because of this. But let's just say you want to assign this to the first machine, okay? So then you see that the finishing time it takes is going to be A1 plus A1. And this is because it takes A1 to finish the first product. Then after it's done, it would be free, so you can do it for this product. So then every time we find a machine to assign it to, we just get the maximum of this sum, and there's our answer for our task A. Alright, so that's just for our task A, but we also have to consider our task B's. So again, Now we're going to given some nodes as well. But now, instead of all the items starting at time 0, they're going to be starting at some time. So for example, before in the input file, in the input pile, all these are going to start at time 0. But over here, they're going to start at like time 1, 2, 3, 1, and 2. Alright, so let's just say, let's call this SI. So this is going to be S1. Like when it's going to be free to get processed by the type B machine. Alright, so I'm just going to put 5 nodes. So again, we're going to have a sorted list of this AI. So we have our A1, A3, A4, and let's just say we have our AM1. Alright, and now we're also going to assume that we're just going to sort this list, okay? Now, we also want to kind of sort this starting positions, okay? So, what we want to do here is that, okay, so let's just say we already kind of like sorted this, this starting position. So, it would look something like this, maybe this, something larger. Alright, and then let's just say we pair it with some machines. So let's actually circle this. Alright, so we might pair with a machine, a machine, a machine, a machine, and a machine or something. Alright, and then you're going to get the maximum one. Then this point or this line over here is going to be our answer. And this is because, okay, so this red part is going to be the time it takes to process, and this blue part is going to be the starting time for this. So I'm just going to use this. So this is going to be S1, S2, S3, S4, and S5. And you may also want to realize that you want to, so now you know that, like right now, you're going to have S1 is less than S2, is less than S3, because of how I drew this over here. And over here, since you want to minimize the maximum sum over here, you want to pair the minimum AI with the largest SI. Okay, so you want to give this A1 or A2. So basically, you always want to assign the minimum. So you want to like the current minimum. Okay. So this is because let's just say we have two items. All right. So we have an S1, S2. Let's assume that S1 is less than S2. And then again we have some A1 and we have our A2. Right. So we can actually just give this some random weight. So we might give this something like 1 and 3 and something like 2 and like 3. Okay. So if we assign, so we only have two options here. So we can give it S1 with A1 and S2 with A2, or S2 with S1 with A2 and S2 with A1. Alright, so we can calculate this. So if we put S1 and A1 together, we're going to get 3. Pretty great. It's a small value. But when you take S2 and A2, you're going to get 6. And S1 and A2, you're going to get 4. And over here, you're going to get 5. and you're going to take the maximum, 5 and 6. Best one is the second option. And over here is because you want to you don't want to put two bigs together, because if you put two fairly big values, you're going to end up with a sum that's bigger. So then if you compare a smaller value with a fairly big value, then you would get a reasonable value. So then over here you want to get the sizes such that a1 is less. So then this would keep on increasing. So then you always pair the current minimum with the current maximum of your S. So then that's kind of basically it. And so we're just going to sort this by increasing height. And then again, we're going to try to assign this, and we assign it, we update this to a1 plus a1. And then we're going to check the minimum, assign it to S2, and we just keep on doing this. So then, again, we also have to keep track, we have to find the answer for a task B. So then, okay, so let's look at the first task, okay? So it's going to be available at S1, and then it's going to get finished processing at time A1. At time S1 plus A1, because it takes A1 time to process and it's available at S1. Okay, so there we go, that's our first value. And then let's just say we also assign this S2 to the first machine. So now what's going to happen is that it's going to be available at time S2. And then time S2, what you're going to do is that you have to spend A1 time on the first machine. And then you have to spend another A1 time on your current machine. So then you're just going to add this up, and that's your current value. So then we're just going to keep repeatedly get this SI plus your current minimum, min AI, and you're just going to take the max of all these values. And that's going to be your answer for your task B. Now, let's go implement this. Alright, so let's implement this. So we have our n number of jobs. We have our M1 and M2, the sizes of our type A and type B. So we're going to have a maximum of 1,000 jobs, and then we're going to have a maximum of 30 of each type of machine. So we're just going to give this M. Alright, so over here, besides our M, we're going to also have our A2 of our M. So we're going to read N and M0 and M1. So we're going to go through each of the type A and type B. I'm going to go through each of these of the number of machines, and we're just going to read in the times. Alright. So now we're going to have is that we also need to, okay, so over here we want to update this A1 to A1 plus A1, and then after this we're going to update, if we use it again, we're going to update it to basically 3 times A1. So to do this, we can just use another array which stores the actual A1, and we can just store another, let's call this B. So this would store our current A1. So this then B of ij would be equal to A of ij. Alright, so now we're going to go through each of our two numbers. Okay, so first we're going to have the time for these machines. All right, so we can have our time, and the maximum number of machines are going to be n. Let's just give this 2. So then what we're going to do first is that we're going to sort time of I plus n, which is going to be the number of jobs. We're just going to sort this by, since we want the largest value, we can just return the bigger one. So now we're going to go through each of these n machines. So now we want the minimum AI whatever machine. So let's call our minimum going to be equal to, or we actually want the index, so we can just extract this with an element b of or we can just use a of I, a of I plus m of I minus a of I. So this would get you the position of this. So let's call you min k. So then what we're going to do here is that we're going to update this value. So then tt, or if I is equal to 0, meaning that you actually want to update the next one, tt of I plus 1, j would be equal to the time it's going to be available. So then this, okay, so let's actually debug this first. So int and int 30. Okay, so we want to update the time. Okay, so this is going to be ti of I of j plus the time it takes for this product, which is going to be a of I of min k. Okay, and this is actually ti. So we also have to keep track of our answer of our current thing, since we want the maximum of these. We want to set to the max of answer and tiij plus ai min k. Okay. So now that we have that, we also have to update this value. So we're just going to increment this by bi min k. Alright. So then let me actually figure out what's wrong with this. Okay, so alright, so that should do. And over here we just want to print our answer. And if I is equal to 0, we want to print a space as well. And we just print a new line. Alright, so let's actually run that. And we have our 5, 2, 3, 1, 1, 3, 1, 4, 3, 3. That's incorrect. So let's take a look at this. So we're taking the minimum element, and we should have our min k. So what we can do is that we can print out the time for this item. So we can print out time I j time ij and line. Alright, so let's go copy this. Okay, so we have our 3, 2, 2, 1, 1, 1. That's correct. So answer would be equal to max time plus time it takes. Right. So let's also print out the time of this I and the min k. So over here the min k is 0 for some reason. Alright, so we have our I from 0 to 2. Oh, so over here there should actually be m of I. Because we actually, since like these sizes aren't the same. Alright, so let's run this again. And 3 and 5 is what we want. Okay, so let's mark this out, make sure we also print nothing. And let's submit this so we have our drop in. Alright. Let's do out. Alright, so problem is job and language is C++11. So let's get over here. And I'm just going to submit my thing. Alright. Submit it. So everything is correct. That's going to be it for today. If you have any questions, feel free to leave them in the comment section below. Bye.